All right, so we have two lessons left within our algebra domain of SAT. Today we're talking about linear inequality word problems, where we'll be looking at linear inequalities as well as with the systems of linear inequalities. So just like with linear equations, linear inequality is very, very common in real life. Now, while linear equations give us exactly one solution, linear inequalities give us multiple values or a range of values that could satisfy the inequality that is given with multiple solutions. So we have to kind of consider that when we're working through and evaluating various solutions as well. A linear system is just like a system of linear equations, except it's composed of inequalities instead of the equations. Systems of linear inequalities are often used to model scenarios that have multiple constraints, and we'll take a look at those as well. And so when we're looking at inequalities, let's take a look up here at these statements. It'll take at least 30 minutes to go downtown. We can model this with a inequality as x is greater than or equal to 30. My time to travel there has to be 30 minutes or more. And so possible solutions include any value that satisfies that. At the low end, it could take 30 minutes. That's the least amount of time it'll take. But it might take more. It might take 31 minutes or 40 minutes or 60 or even 600 minutes to get downtown. Any value greater than or equal to 30 is a possible solution. Likewise, I refuse to pay more than $6 for a sandwich. And so x has to be less than or equal to 6. So again, the most I would pay is $6, but I'll also pay any value less, such as $5.99 or maybe $3.50. I'll even take a free sandwich. All of these are possible solutions. It's helpful to take a look and study this chart a little bit on your own and comparing the phrases to how they translate when we're looking at greater than, less than, greater than, or equal to, or less than, or equal to. Let's spend a little bit more time talking about systems of inequalities and the fact that we have multiple constraints. Okay, so say you're buying snacks for a party. Well, you're going to have two constraints. You're going to want to make sure that you buy enough food so that you don't run out, but you also want to make sure that you don't spend too much money on lobster and caviar. So you have these two constraints. You need to make sure you have more snacks than what people will eat, but you want to make sure that you don't spend more money than what you have for budgeted for the party. If you manage to make both of these things work, buy enough snacks without breaking your budget, you've solved the system of inequalities. And just like with linear inequalities, how we have multiple solutions that could work, a system of inequalities also will have multiple solutions that work. You have a little bit of wiggle room. If you buy the name brand chips, then you might have to buy the off-brand cookies. But if you buy off-brand chips and cookies, then you might be able to afford more of those things. So there is some wiggle room within those constraints for how you solve the system. So let's start by looking at some simple inequality word problems. Ari can harvest at least 48 pounds of honey from her bee colony. If she wants to package the honey and harvest in 1.5-pound jars, what is the minimum number of jars she can fill? So again, it helps to rewrite this in a sentence that we could easily convert into an algebraic statement. And so we have to think about what we are modeling here. And so the first constraint is that she has at least 84 pounds of honey. So that's always a good place to start, is what the inequality is going to be. So we have at least 48 pounds of honey. Okay. Now, she's harvesting that honey and she wants to package it. And so now we have to look at the packaging portion. She wants to package the honey in 1.5-pound jars, and we want to know the minimum number of jars. So since that's what we're solving for, that's going to be our variable. So J equals jars. J equals jars. So we have our variable, and so now we need to use that to model the rest of the equation. Well, if we know that she's going to have a certain number of jars, the amount of honey per jar, when we combine all those jars together, have to give us at least 48 pounds of honey. And so now we can go ahead and kind of translate this. The amount of honey per jar is 1.5 pounds. I'm going to write that a little bit neater. 1.5 pounds per times J, the number of jars. And that has to be at least, which is our inequality, greater than or equal to 48 pounds. So we have our inequality, 1.5 J is greater than or equal to 48. And now we can go ahead and actually solve for J. If we divide 1.5 on both sides of our equation, J has to be greater than or equal to 32 jars. So we know that she's going to need at least 32 jars of honey. If she has a larger honey crop, she's going to need more jars. Brian wants to make peppermint stick pickles for his friends. The snack was made by inserting peppermint sticks into the middle pickle. If a peppermint stick costs 40 cents and a pickle costs $2.30, what is the greatest number of peppermint stick pickles Brian can make if he has $20 to buy the ingredients? Okay. So getting over the fact that peppermint stick pickles sound like they are completely disgusting, what we were trying to do is model the scenario, and it looks like Brian's trying to make a bunch of pickle stick snacks, but he has a budget. And so let's start with that. He only has $20 to buy ingredients. So he has $20 or less to buy ingredients. Okay, so he has $20 or less to buy ingredients. And then we have to figure out, okay, well, how much is each pickle going to cost? Well, for every pickle, there's the cost of the stick and the cost of the pickle for each snack. So we've got the cost of the stick and the cost of the pickle for each and every snack. So this is kind of in a couple parts. We have the cost of the stick is 40 cents, and the cost of the pickle is $2.30. And those get combined for every single pickle. Let's use P for pickles, okay, for each pickle snack, or let's use S for snacks, okay? So for every single snack, it's going to cost 40 cents plus $2.30. We're going to multiply those together. And the total bill has to be less than or equal to our $20 budget. And so we can simplify this as 2.7s less than or equal to 20 so that we can solve for the amount of pickles. And so if we divide both sides to solve for S, S is less than or equal to 7.407, and then there's some rounding that goes on there. And so at most, he can make 7 pickles. Okay. Last of our linear inequalities. Zoe has $5 and wants to rent a scooter. The scooter costs $1 to unlock and 25 cents for each minute of use. Write an expression for the total cost in dollars of renting the scooter if Zoe uses it for X minutes. So first we have to start with what the condition is. Well, she has $5 to spend. She wants to spend no more than $5. And then within that condition, We have the cost to rent the scooter. Well, there's two costs associated with it. There's an unlock cost and a cost per minute. So we can translate the unlock cost. That's going to be a constant fixed value at $1. And if we add in the 25 cents per minute, that total cost needs to be less than or equal to the $5 that Zoe has to spend. So our inequality is 1 plus 0.25x is less than or equal to 5. And if we wanted to solve that one, we could, but we don't need to. All we need to do was find the expression.